Okay guys, this is another tutorial or another continuation of our shell basics class. Okay, so this is shell basics day 2 part 3. So if you have not seen the 2 part 2, you see a link here, click on it and then you'll be able to access that. And in part 2 of day 2, we stopped at the string tokenization function, which is to help us tokenize and to split our string, right? So that being said, we are going to the next concept, which is executing a program. Please give me a second. Yeah, so the noise will be reduced. Okay, so executing a program. So the system called execve, right? So we have this function called execve, and it is a system call, which means it is defined in our unistd.h header file, right? It allows a process to, so we've done process before, right? So we said, let's say we have our process guy. Where is it? Okay, yeah, this is our process. Okay, I explained fork basically somehow. Okay, good. So we said a process is, okay, when we execute it has a process. For example, this can be one process, right? So when we execute a file, it's held in this process, right? So it says the system called execve allows a process to execute another program. So for example, let's say I want to run a program. um, let's say I want to run a program sum, right? Sum would print out this thing, but if I use the exec ve inside this sum, instead of running this command, it's going to replace it with whatever program I put inside that function, and then it will terminate this one. Okay, so the exec ve allows a program to execute another program, allows a process, so that process will execute. Process is normally supposed to execute sum in this instance, but it will not, execve will not allow that process to execute this guy. It will make it execute a new program. Okay, so which is going to be passed into this function. So you say you should man to execve. Okay, so we'll do that. Let's man to execve. Okay, so this is it. So it is defined in the unistd, right? So we want to execute another program, so the path name to that program that we want to execute will be this guy. Okay, and then after that we can have a command line argument to that path name. Okay, so we can have normally so normally we can add that sum, and then we can have like, yes, a command line argument, right, to it, right? So for example, sum 2 and 3, these are command line arguments that I've added to it, and because this sum is a command line execution file, so it accepts it and then use it, right? So we can have this command line argument to it. Okay, so let us clear, and okay, so back to the concepts. So basically that's what, okay, yeah, let's go to man this guy. So basically that's what this guy does. Okay, it holds that argument, and then we have this environment variable, right? This guy is the one that, okay, let's see, execute the program referred to by path name. So normally we will talk about this guy. So the exec function, it says it executes the program that we specify in path name. This causes the program that is currently being run by the calling process to be replaced with a new process. So anything that is under the exec will not be run. It is just this one that will be run with newly initialized stack heap, blah blah blah. path name must be either a binary executable, it has to be an executable file, or a script. So we can either use it for executable or a script. Okay, so if you are using it for script, they said it has to start from with interpreter, right? So the execve is an array. So this second one, which is execve, is an array of argument string passed to the new program. So these are the arguments, command line argument, that will be passed to the new program. By convention, the first of this string, this guy, would be the file name, right, associated with the file being executed. envp, which is the last one, is an array of string as well, conventionally to the form key equals value, which are passed as environment to the new program. Okay, so this guy for now won't really take into consideration a parameter for it, but the thing is, each command line argument for this exec should end with a null, and this guy also should end with a null when you are writing your code. And then I think that is being said here. The execve and envp arrays must each include a null pointer at the end of the array. Okay, so the argument vector and environment can be accessed by the core program's main function that is defined as blah 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 blah. So we can access that through that. And what else? So another thing is that it does not, on success, exec will not return anything. The reason being that if we have a program that is running already, and then we've used this exec, where is it, we've used this exec. Okay, let me use this example. Good. So if we have a program that is running normally, right, so this guy is supposed to print before, and let's say it doesn't do anything here, and it's supposed to print after normally, but because of it will print this before, it would, with passing exec, because we pass in exec would make it only do this thing after that part, and then it will truncate this place, because exec would replace whatever this program is supposed to do with itself and nothing else. Okay, so that's what happens. And then because of that, this return 0 will not return, so it will not return anything. But if exec did not work, we'll have a return, right? If exec fails, we'll have a return. Okay, so that's what that place is saying, that exec does not return on success, and the text initialize data initialize data bss. Wait, I'm coming. Where is the return? Does not return on success. Okay, it does not return anything. Wait, let me just see. There's a place where we should see the return for this guy. Let me just search for return. Oh, so many return. Let me search for capital letter return. Okay, probably there's no pattern like that. I'm trying to see, so but there are so many return there. Okay. So on failure, it's supposed to return -1. So I'm trying to see where that part is stated. Probably I've seen it and I've skipped it. Anyway, so let's continue. Probably if I see it, I'll let you know, or you can check it on your man, because I'm in a hurry, kind of. Okay, on success, exec, this return that I'm looking for, look at it. On success, exec does not return. On error, -1 is returned, is set appropriately. Okay, so that is that for now. Okay, good. So if you look at the prototype, right, okay, we have this, right, we have int this. So let us go to the concept and see again. So it says that the system exec allows a process to execute another program, right? Okay, note that this system call does load the new program. It will load the new program, right? So this system call, if you do execve, it will load whatever you put inside exec into the current process memory in place of the previous. So you know, when you are executing a program, the program is being placed into the memory, right? But exec would now help it replace whatever is being placed there before with its new one, right? So on sources, exec does not return to continue the rest of the previous program. We've said that. So warning, in this example, execve is used without the current environment last argument. So the last argument here in this example as well, they didn't pass a parameter to it. Okay, so you should not forget to add it in your shell. Okay, so basically, if you look at the exec, right? Okay, so they declared an argv here, right? So it's being passed a path name. That's we are saying that we want to execute this file called ls. So if I do on my command prompt, if I do which ls to tell us, which ls to tell us where our ls is, you see that our ls is in our own user bin ls, right? Okay, so probably theirs is in bin ls, right? Okay, so they pass it that, okay, I want to execute ls in bin ls, right? And then this argv is the whole part, right? So argv normally is not really the whole part, but let's see, argv is containing the whole part, right? But the thing is, this guy should always end with null. That's why this guy is ending with null, and the other guy should always end with null, but they didn't pass any parameter to the last guy, which is the environmental variable, right? So this argv now, okay, it ends with null, and then it will have some parameters, right? So it would have some parameters, which is going to be our argument that we want to command line argument to this guy. Okay, so that is that. So if it returns -1, right? If this guy return -1, it should print error. If not, it will just execute this guy and leave this guy, because this guy has been cut off. Okay, so by the time they execute this command, we will have a it's going to list our directory -l, because I think what it does is that this bin is a command, and then it takes this command line argument -l. So I don't know why this one is here. Normally, probably this guy is supposed to be here, but let us execute this guy and see if it's going to execute, right? And then we'll touch it and use it to do some tricks and see what we'll get. Okay, this guy might not execute because our directory is different, but let's see. It is called exec.c. So via our exec.c, right, paste it, and then we'll come here, page down, gcc. So we'll copy this guy and paste it. Okay, so let us, so this guy actually worked. It actually worked, right? So it listed it. So let us vi our exec.c. Okay, so let us see if we can do some things to make us understand better. Okay, so normally this guy will get what's it called, path to what we want to execute. So let's say our ls is in what, user bin. So let's say this guy is /user/bin/ I'm just trying this, I've not tried it before, ls, right? So it means that, okay, we've passed this to this. Okay, so this guy is going to be let's call it v, and then this one, let's call it our environmental variable. Right? Okay, so we'll declare it here. So we have a char pointer to v. Okay, we have that already, so let's declare this one as our envv. So we'll call this one null. We initialize it to null, right? So right, so let me just put it in curly braces. I don't think it's necessary. Okay, so that's that. So we are replacing this guy to be null, right? Okay, so our part is this guy, and then we want to pass in an argument to this guy. So we pass in our argument and say our argument is l dash l. So we pass in dash l. Let's see if this guy will work, right? So we are passing dash l to this argument, right? And see. So let's clear and compile. Okay, and as you can see, it is listing okay, it is listing our, it is not doing that dash l, it just listed it, right? So let us see again, vi exec. Okay, so I think we have to pass in two arguments here. So this one will do ls. Okay, I think I get what is wrong. ls first and then dash l. Okay, let's see. So let's compile. Oh, sorry. And then let's execute. So it printed it in the wrong format. This thing actually worked. So let me show you what I did, right? vi exec.c. Okay, so basically what this thing does is that we put that, okay, we have an executable file in this place, right? Okay, what are the arguments we want to do? If you do ls alone, it will list it, right? If we do ls and then dash l, it will list and then in long format, right? So these things are already set on our shell, and then we'll end it with a null, and then the second one we don't pass anything, we just end it with a null, right? And then it's going to execute. I don't know if this gives a clearer picture of what it does. Let me go once again. Normally we are supposed to execute this program, right? We are supposed to execute this program. It's supposed to go line by line, right? It's going to know that we've saved this guy here, print before. Okay, if this guy wasn't here normally, it will check, and then if it is not -1, it will not print everyone, and then it will print after. But because when it gets a print before, and then when we pass in this execve function, it will execute this guy and then truncate whatever is left, right? So because of that so it will just execute this guy, right? So now exec function collects three parameters: an executable file. This is our executable file is here. So if you go to user bin and ls, we'll be able to see this executable file ls, right? So ls, that executable file, if you now pass in an argument ls to it, right, it will just list. If you do ls and then you do dash l, two arguments now, it will list and then in long format, and then it says that everything must end with a null. So our this guy, we are not passing any argument, so it ends with null, right? And then we say if it is -1, it is error. If it is not, it should just execute it, and then it executes the command. And that's what exec does. It helps us to replace a running program with another one, right? Truncating the first one and executing the new one that we pass into it. Okay, so I hope this understand explains the concept. Okay, so that's that, and then in the next one we'll be going to using the fork itself and then to create process. So see you. So I think we're gonna have one more for our day 2 and then we'll move to day 3. Thank you. Bye.